Welcome back to Math Caffeine. This is the final part of the parallel and perpendicular lines series. Let's get started. Important terms to know. A directed line segment is a line that represents moving from point A to point B. Point P is a point on the segment that shows how far from point A this moving object has gone. This is often shown by a ratio. To find the coordinates of point P, given the ratio of AP to PB, follow these 4 steps. Step 1. Divide the segment into parts so you get a fraction for segment AP. For example, if your ratio was 3:2, then you would divide it into 5 parts and make 3/5 your ratio for AP segment. If your ratio was 4:7, divide it into 11 parts and use the fraction 4/11 for your AP segment. Next, find the slope of AB using the formula of a slope. Step 3 is to find how far point P is from point A. The first thing you would need to do is use the fraction you found in step 1 and multiply it by the rise and the run of the slope of segment AB. Make sure to keep them separate. Then add the final answer of the run to the coordinate of point A and add the final answer of the rise to the y-coordinate of point A. These new coordinates are the coordinates of point P. Important theorems and formulas you need to know. If 2 lines are parallel, then their slopes are the same. If 2 lines are perpendicular, then the product of their slopes should equal -1. To find the slope, you need the coordinates of 2 points on a line, then find the change of y over the change of x. Finally, the slope-intercept form, or the equation of a line, is y equals to mx plus b, where x and y are coordinates to a point on the line, m is the slope, b is the y-intercept, and also where the line crosses the y-axis. Another major part of this next section is to know how to find the distance from a point to a line, given a point and the equation of another line. Remember, the distance is a line segment that is perpendicular to the line given. Step 1 is to find the slope of the line that is perpendicular to the given line. Step 2 is to find the equation of the line that is perpendicular to the given line using the point given. You should now have the equation for the 2 lines that are perpendicular. Using those 2 lines, find their intersection using any method you learned in Algebra 1, like substitution or elimination. The last step is to use the point you found in Step 3 and the given point, and use the distance formula to find the distance between the point and the line. You can get good at these multi-step problems with lots of practice. This concludes our series for parallel and perpendicular lines. As always, feel free to email me with any comments, questions, or concerns at mathcaffeine@gmail.com. Happy studying!